Hi everyone, welcome to lesson 21 of the Advanced Higher Stats course. In this lesson, we'll be looking at most of the t-distribution hypothesis tests. By the end of this lesson, you should be able to do a one-tailed and two-tailed population mean test and a difference in population means test. We'll start off with a one-tailed test for population means. A company claims that the average delivery time for their online orders is less than 3 days. To test this claim, a random sample of 18 orders is taken. The sample mean is 2.8 days and the sample standard deviation is 0.5 days. Conduct a one-tailed hypothesis test with 5% significance. The reason we're doing a t-test here and not a z-test is because the sample size is less than 20, so it's small, and we don't have a true standard deviation, we're using a sample standard deviation. Let's start off here with writing the hypothesis. So H naught is mu is equal to 3. The true average delivery time is 3 days. And H1, the alternative hypothesis, is mu is less than or equal to 3. Next, we need to find our critical value for t. And first, we need to find the degrees of freedom for that, which are run like this. In this test specifically, degrees of freedom is just equal to n minus 1, which is 18 minus 1, which is 17. So what I'm looking for t 17 and then 0.95. That's our critical value. And that would give us 1.74. And next we find find our t value. T is equal to 3 minus 2.8 over s, which is 0.5 over root the sample size, which is 18 because of the standard error. And that gives us 1.7. 1.7 is less than 1.74. Therefore, not enough evidence at 5% significance to reject H naught and suggest the average delivery time for online products is less than 3 days. Next, we move on to a two-tailed test for population mean. A pharmaceutical company is testing a new drug for pain relief. A sample of 16 patients undergoes treatment, and their average pain reduction is compared to the expected average pain reduction of 15 units on a standardized scale. The sample mean is 13.5 units, and the sample standard deviation is 2 units. Conduct a two-tailed hypothesis test at 5% significance level to determine if the new drug has the expected effect on pain reduction. We can use a t-test here, and we're not using a z-test because, again, sample size is less than 20, and we are using sample means and sample standard deviation. We start off with our hypothesis. H naught is that mu is equal to 15, which is our expected pain reduction, and H1 is mu is not equal to 15. We find our t value here, our critical t value, which is 15 degrees. It has 15 degrees of freedom, and is 0.975, and that gives us 2.131. Next, we find our t value. T is equal to 15 minus 13.5 over s, which is 2 over root sample size, which is 16, and this gives us 3. Since 3 is greater than 2.131, therefore enough evidence at 5% significance to reject H0 and suggest the new drug does not have the expected pain reduction value. And finally, we move on to difference in population means. Compare the mean math scores between students who underwent education A, 18 students, mean 85, standard deviation 8, and education B, 20 students, mean 88, standard deviation 7. Conduct a two-tailed t-test at a 5% significance level to determine if there is a significant difference in the scores. The first thing I do here, I will label all my values and give them either 1 or 2. So x bar 1 is 85, S1 is 8, N1 is 18, x bar 2 is 88, S2 is 7, N2 is 20, and then we write our hypothesis, which is H naught being mu1 minus mu2. The difference between the two scores is 0. There's no difference. An alternative hypothesis is mu1 minus mu2 does not equal 0. There is a significant difference. Now we find our critical t value, which actually is given in the formula here on page 6 of the day booklet. And it's n1 plus n2 minus 2. So that is 18 plus 20 minus 2, which is 36. 36 and 0.975, which is 2.028. Next, we need to calculate the t value, but before we do that, we have to calculate this s value. So s is equal to n1 minus 1, 18 minus 1 times s1 squared, 8 squared, plus n2 minus 2, which is 19, or 20 minus 1, times s2 squared, which is 7 squared, all over 18 plus 20 minus 2, which gives us 56. And I should credit this s squared we're calculating, not s. And then to get s is the root of 56, which is 7.49. And now we can finally calculate the t value. So t is equal to x bar 1 minus x bar 2. So, or we can even solve that round, it doesn't really matter. I'll do that so our value is positive. 88 minus 85 over s, which is 7.49, square root 1 over 20 plus 1 over 18. And this gives us 1.23. 1.23 is smaller than 2.028, the critical value. Therefore, not enough evidence at 5% significance to reject H0 and suggest there is a significant difference in scores. That is the end of this lesson. Now you should be able to do these 3 t-tests.